This is basically a continuation of ISI 2009, question number 10, part 2. Now there are 3 applicants, student 1, student 2, student 3. Each of the student can get anything from a uniform distribution between 0 to 100. The college will firstly reject this one, then reject this one, and then it will have to accept the third student. Obviously, the highest mark of a student, they'll want to select that student. Okay. So after having rejected the first 2 students, student number 3 can get anything between 0 to 100, and the expected mark will be 50. Okay. The second student we saw in the first part. In the first part, we saw that. No, I'll share. Okay. If I will be accepting the score of the second student, that distribution will be from 50 to 100, because anything lower than 50, I will be rejecting the second student, right? Anything lower than 50 for the second student, I will be rejecting him, because I know that if I reject him, I will expect to get a score of 50. So why should I accept a score lower than 50 for the second last student, right? So the distribution of the marks of acceptance, for the second student will be between 50 to 100. And if I consider a uniform distribution between 50 to 100, the expectation that I will be getting will be 75. The expected score that I will be getting will be 75. Now, I go back to student 1 now. So what am I doing? I'm going back. Suppose I reject both of them and then I go to this. Suppose I reject the first one and I'm sitting on the second one, then I'm getting this. Now suppose I have to decide whether to reject the first student or not. Okay. Now, if I have to decide whether to reject the first student or not, I call a threshold A, below which I will be rejecting the student. Above A, I will be accepting the student. Okay. Now, what should A be? A should be the expected score. If I reject the first student, I should get A. I will expect to get A. A should be that. It's not 75. Let's come to that. If I reject the first student, I go to the second student, right? The second student can get anything between 0 to 100. Can get anything between 0 to 100, right? So if the second student gets a score of say 45, or a score anywhere in the region of 0 to 50, I will be rejecting the second student. So if I reject the first student, in the second student, with probability half, the second student will get anything between 0 to 50. With probability half, the second student will get anything between 0 to 50. It's a uniform distribution. 0 to 50 is equal probability as 50 to 100. Right? So 0 to 50, if he gets any marks, I will be rejecting the second one also. And my expected score will therefore be 50. So half is the probability that my expected score is 50, and half is the probability that the second student will score between 50 to 100, and the expected score will be 75. Let me repeat. If I reject the score of the first student, I go on to the second student. The second student can get anything between 0 to 50 with probability half. And in that case, I will get an expected score of the third student, because I will be rejecting the second student also. So half is the probability that I will be rejecting the second and getting an expected score of 50. And half is the probability that I will be accepting the second student if he gets anywhere between 50 to 100, multiplied by the expected score of the second student. So this gives me 62.5. So if I reject the first student, I will expect to get a score of 62.5, right? So I should accept the first student only if he gets a score higher than 62.5, and the score of acceptance of the first student will be anywhere between 62.5 to 100. Am I clear? So what is the lowest mark for which the college should admit the first student? Answer is 62.5. What is the lowest mark for which the college should admit the second student in case the first is rejected? Answer is the same, 50. In case he rejects the first student, what is the lowest score for the second student? 50. That is similar to the first part. Am I clear? Okay.